In this video, I will teach you the radiation and convection and latent heat that result from a bud, and we consider the bud as a sphere. Firstly, for radiation of bud, there is three types of radiation: incoming shortwave radiation, incoming RNS, that is incoming from the air and from the air to the sphere. It is incoming. RNL is incoming long wave radiation, and the emitted radiation that go from the sphere to the surrounding. There is three types as mentioned before. For coming short wave radiation, we have the law of RNS equal to AD over A 1 minus alpha RS. For the AD over A, that ratio express the surface exposed to the radiations, and that's changed from 1 to 0. We can go here in this reference to say it is taking as 0.6 approximately, and R is equal to 40 as shared. Okay. AD over A values were estimated before exposed images. That's okay. And AD ratio were set as 1.8. That's okay. That's okay. As we can see, the sphere have a high value of this ratio, because it is a small surface for a sphere that's not have the sun direct. Okay, go here. Alpha equal to 0.6 as approximation, depend on this is about is the type of fruit, and this a mean value, and R is equal to 14, and that's for air. You can research on it. For RNS, okay, it is equal to when you give these numbers, we have this number watt per meter square. For the second type, RNL, it is equal sigma A R alpha TA for NL equal to epsilon A sigma TA power 4 positive AR over A epsilon J T ground power 4. When says this law, we can determine two types of radiations coming from the air and the ground. Epsilon air is the emissivity of the air, and we can determine this value from from the law in this paper. We can go here in appendix and see this in this appendix to calculate epsilon A equal to 1.72 EA over TA power 1 over 7. And we can estimate it EA from this law at T dew point. And T dew point for the air, we can, when we give T dew point for air when temperature equal to negative 10 degree, and the T dew point, you can go to a psychometric chart to determine the point at 9 is equal to negative 15. Okay, we can go here and continue. TA is temperature of air, and this term determine the radiation the radiation by the ground, because there is a radiation. Okay, so we can go here to have A R over A epsilon J, and this the emissivity of ground, and we can go for table of emissivity of materials, and have that the emissivity of ground is high, and it is from point A to point 9. T ground, it is the temperature of ground. We can see that we assume that the temperature of air is it is about negative 9 Celsius. It is equal to 263 power 4. This is in Kelvin. We must transfer Celsius degree to Kelvin degree, and we can hear that it is T ground as the same of temperature of air, because that is the assumption, and I think the temperature of ground, it is mainly equal to the air, or less or more than with small value. So that's the air and the ground is equal. We can have the RLN is equal to 254 watt per meter square. The third type of radiation is the emitted radiation, and this radiation is go from the bud to the surrounding, because the bud is the temperature of the bud is equal to 5 Celsius, so it is higher than the surrounding, so there is radiation from the sphere to the surrounding. How can we calculate this? By this relation, RA equal to epsilon F sigma TP os 4, and epsilon F, it is the emissivity of the bud, and we can go here to this reference and have the emissivity of the bud, and it is equal to between 0.9 to 0.95, 0.95 or 1. It is a mean value, and we can research it to have this in this paper. Okay. For this is a constant and equal to 0.5.67 10 power negative minus 8. Okay. And TB is the temperature of the pad for power 4. And this is go to the final number is 5.38 10 power minus 8 TB for power 4. We can have that in this relation of radiation, the final relation of radiation is RA minus R. When have the final relation, we can have that the R total is depending on the TB for power 4, and we have the value when go to this file. We have the value of TB from 5 to minus 50, and when we have this value in this law, we can have the value of R total, and R total when is B positive, this means that the radiation from the sphere to from the sphere to the system is more than the incoming radiation, and when B a negative, it is the opposite. That's R total. We must have this relation to have the QR in watt. So we have this the surface area of the sphere. It is equal to by multiply the square, and the square equal to 7.35 multiply 10 power minus 3. So we have this the final number here for the QR or the Q radiation or R total as the radiation total of radiation. Okay. The second type of heat transfer from the sphere to the surrounding is the convection. And the convection mainly depends on the difference in temperature between the temperature of the surface and the temperature of surrounding. As you can say, QC equal to AC multiply HC multiply TB minus TA. This is the surface area of the sphere, and H is the heat transfer coefficient, and TB is the temperature of the surface of the pad. T is the temperature of the surrounding. Okay. To have the HC, the heat transfer coefficient, we must determine the real number, and real number was given by this relation. Real number equal to U multiply D over nu. U is the velocity of the air around the sphere, and it is equal to 2.2, and this measured by a management device, and D it is the diameter of the sphere, and from table of air, and this value we can have Franco-Corbera to have this value. So real number equal to 1324. Okay. For relation of Nu, that's the Nusselt number. The Nusselt number have this relation from the Franco-Corbera, It is the Nusselt number for the sphere. It is depend on Rayleigh number and Brighton number, and mu over mu s. Mu over mu s, it is a relation, and we can assume it to be 1. Okay? Mu, this is value. Can you have this value from the tables appendix in Franco-Corbera, and have this mu and mu s, but it is a very small. It is a very small to have to express these values, or that use it is 1. Yes, you can go here to make a check in this paper. The authors, I found the author to get it equal to 1. Okay. Brighton number, also you can have Brighton number from the Franco-Corbera, and this is all parameters depend on the temperature. Here you can go to appendix. Okay, here appendix of Franco-Corbera. This is appendix P, and go to properties of air. Go to properties of air. You can search here appendix A. Okay, it is here. You can go to properties of air. The thermodynamic properties of gases at atmospheric pressure. Can go to air. This value of mu. You can go here for the value of 2063 in Kelvin, and have the Brighton number and this value of mu. And finally we have that Hc equal to 50 watt per meter square dot Kelvin. Okay. What is there is a relation. I have the value of Hc by Nusselt number. Hc equal to Nusselt number multiply K over D. Okay, when you have the value of Nusselt number equal to 15, and express here, we can have the value of heat transfer coefficient equal to 50 watt per meter square dot Kelvin. Okay. For K, it is equal to 0.023 from the air tables. Here, from the air tables, we can have the value of air of K, and the K, it is the conductivity parameters for the air. As you say, it is a heat transfer, and heat transfer relationship depend a lot about the properties of air, because air surround the sphere, and the air transfers the heat from the sphere to the surround. So mainly all properties depend on this. Finally, we have the QC equal to 50 multiplied by d square as the surface area multiplied TB minus TA. Finally, we have QC depend on the TB. After all that we have been finished studying the two types of heat transfer, radiation and convection. Finally, we have to study the freezing of the water inside the sphere, because because there is at 20% of water inside the sphere. Because so we firstly determine the start point of freezing. As it depends on mainly on the type of this water, because if this water have some impurities or salts or other material in it, the freezing point start point will change. As you can see in radiator of the car, the water will change to solid as ice if the temperature go to under 0 Celsius. So in the very cold countries, very cold countries, the designer of the car put some materials in with water so that the starting point of freezing go down until maybe until to minus 40 degree of Celsius. So a starting of freezing of bod we assumed to be have to -5 as your graph, or merely as the impurities in the pot. And this have a relation with pressure, but we can't determine this by pressure or impurities because we don't have the complete compensations of bud, so this value is mainly depend on the graph that you send. Okay. The latent heat that emitted from the pod when freezing can calculated by QL equal to m dot water H. M dot water, that is the water stored in the pod and it will transfer to ice. H is the latent heat of the water. So we have a relationship from this paper to use, okay, this paper in freezing and thawing of foods, computations, method and thermal properties correlation. This figure in USA, and we can see in this paper the author find a relation figure between the temperatures and the H, because between the temperature and the H, and with our for starting and to produce relationship between each various T. Okay, from and think this is the reference I used. Introduce a relation between each versus T. The quantity of water M dot equal to 20% of the total mass of the pod. So the total mass of the pod equal the total mass of the pod equal to rho V over T. Why over T? Because we have the mass 2 times. We have kilogram per second. Okay? Rho, it is the density of water, and V is the volume of the sphere, and it's equal to 4 over 3 by the power 3. It is multipliable to multiply to 0.12, multiply by 2.02. Okay, and the t it is the 3 hours, so we change it 3 hours to seconds. 3 multiply 60 multiply 60. Okay, it is the rho, it is volume, and the final number is 4.1 multiply 10 power minus 7 kilogram per second. We chose 4 points calculation for QL, well done with percentage of water that freezing. Okay, we got here to have this Q equal to m dot water for H, and when with the minus 5 temperature, we go here to have the we go to this relation to have the value of H. Then we go here, it is equal to 120 multiply 1000. It is the value of H, and this is the value of water, and 10 power 6 to okay. We have this the value of not watt, it is microwatt because we multiply here by power 6, so this value it is not watt, it is microwatt. So sorry for this is microwatt, and here we can have the value of H at minus 7.5 at this point, and have okay, and the same method at minus 10 Celsius. This milliwatt. So we have the relation. This is the QL. You can see from 5 to minus 5 there is no latent heat because the freezing start at minus 5. Okay, we can see here the relation. Okay, finally, to have the total heat transfer over the surface of the sphere, we must make a summation for this three value, but QC, QL, and QR. Finally, we have this column to determine all heat transfer. We have this value at this value, so we go to grapher to make a drawing for this relationship and have the relationship between temperature and we have a relationship between temperature and heat transfer. We have this relationship between heat transfer and temperature. We have there the beginning of the freezing near to minus 5. In this figure, someone can ask me why this a big valley and it is go down. If we can see that the temperature of the bud is 5, here 5, and the temperature of air equal to minus 9, so the difference between them is a maximum, and when we translate to minus 2, we have a heat transfer less than the value at 5. Why? Because at 2 we have a small difference between the temperature of surface and the temperature of wood comparing to at 5. Okay, that's the value of heat transfer decrease until we beginning to freezing, because freezing emitted heat transfer to surrounding to so that we have increase in heat transfer here until have the peak. Then the heat transfer decrease because the temperature decrease, and heat transfer convection or radiation decrease, and the latent heat decrease until near to 0. Okay, I hope this video is be useful for you. Thank you very much.